Un, 2, 3, 4.
With us today, and it's really interesting for us since we are often in the world of biofuel, and our people that we invite are working in biofuel, like biochar, biodiesel, and so forth. So now it's the first time that we have invited people that are related to food engineering and food science. And it's pretty cool because we have been working on the maple syrup technology. So these guys are going to help us know a little bit more about what's going on, especially in terms of wine production, because those guys are related to wine and food analysis. So sorry about that. I'm going to briefly introduce our guest. So first of all, Emanuele Boselli is an associate professor in food science and technology at the Free University of Bolzano and head of the research group in enology, so EnoLab. His main research activity focuses on studying the effect of raw material quality, production technology, storage condition, and packaging material on the quality of wines, spirits, and food products. Since 2017, he has been responsible for the Unibiz profile in the master's degrees course in viticulture, enology, and wine market. So this is interesting since some of the work that we're doing in the maple syrup is fermentation to produce, it's not wine, but some kind of a wine, and we're producing distillate as well. So it's pretty interesting for us. And Eduardo Longo is a researcher in food science and technology at the Free University of Bolzano in the research group of enology. So he's also in the EnoLab. Main research activity are the analytical investigation on the chemical composition from grapes to wine and the application of statistical methods to highlight the relationship of the chemical profile with winemaking operation and with the resulting sensory traits. His didactical activity includes master degree course in analytical methodology in wine analysis and PhD course in multivariate statistics applied to food analysis. So guys, really thank you for being with us today. It's an honor having you here and showing us what's going on with the wine science in Italy. And without further ado, the floor is yours.
Okay. Thank you, Jean-Michel, for your very nice introduction. I hope you can hear me. Yes?
Yes.
Great. Thank you for the invitation. I'm very happy to present, to introduce you to to the region, to our university, and to our research center. So maybe this could, as I said before, this could trigger more collaborations, even if the field of research are a bit different, but contamination is always a very good starting point, I think. I will share with you my presentation. Of course, this can be, I can share it with you as a file later. Can you see it, the first slide?
Yes, we
can. Yes.
Okay, perfect. So the title that we have chosen together with Eduardo is Low and High Resolution Analytical Methods as Components of a Decision Support System in the Wine Chain. This means that we are using, let's say, routine techniques and high resolution techniques for the characterization of the quality of many products of the wine supply chain, from ingredients to masts, in the specific case grape masts, or fermenting grape masts, and also finished wine, packaging material, which are very important, closure systems, and I will mention some studies we did on closure systems. And not only let's say not only wine, but I will talk also about a spirit drink which comes from wine, a grappa. Maybe you know some. So this product is the product of distillation of fermented grape pomace. Okay. This is our region. I don't know how much you know of our region. We are here in the northeast of Italy. This is Venice. This is Verona, and Milano is here. And so we are locating at the border between Austria, Switzerland, and the region is called Alto Adige because Adige is a river flowing through our valley from here. This is a zoom of this picture. The capital city, it's a city with 100,000 inhabitants, is called Bolzano in Italian and Bozen in German, because we are at the crossing point of two cultures, two languages, two populations. Well, not only two populations, because there is also the local population, which is also another language group. So we, since 1,000 years, there is a mixture of the different cultures, the German, the Central European ones, let's say, and the Mediterranean culture. This is a view of the outskirts from Bolzano, taken from the north. So if I look at from the north to the south, this is what you can see, the town, the mountain here in the middle, which is this mountain here, and then viticulture areas. You can see here in this other map, all the purple spots are viticultural areas. So all in the flatland of the valleys, but we can start here, which is this part of the province is 200, more or less 250 meters above the sea level, up to 1,500 here, for instance, 1,500 meters above the sea level. So we are talking about mountain viticulture or heroic viticulture to produce extreme wines. Let's see if it goes. We can go further. So this is a nice picture in the sun in the summer. Our practically the central seat of our university is where you can see this reflex. However, our lab is more or less here in the outskirts of the town. We, as an Italian viticultural area, Alto Adige, you have seen there is not a big area in which viticulture can be practiced because we have mountains. It's a mountain area. So we have the 0.7% of the domestic production of wine. So it's 350,000 hectoliters of wine per year. But hundreds of wineries, because they are family-run businesses. We have local varieties, which are known probably here, like Gewürztraminer, though this is also present in France and in Germany. Schiava, Fernache, Lagrein. Local varieties are very important. To be honest, Italy has the highest number of local grape varieties compared to other countries. There are hundreds and hundreds. But we have also Pinot Blanc, Sauvignon, Pinot Noir, both red and white varieties. The important point here is the focus on the quality. So the local wine production belong to protected designations by 98% of the total production, compared to the rest of Italy, which the percentage is much higher, because in Italy we have 30–40%. Here, most of the wine has a special designation of origin. This usually means that the quality is higher compared to other, it's not table wine, it's a DOC wine, or appellation wine, okay? Most of the wines are white, only 40% are red. And here you can see some vineyards very close to the Dolomites. Dolomites are, maybe somebody of you already know that Dolomites are UNESCO heritage, and so we have, as you can see, a policy which is very strict of environmental protection and due also to the tourism, to the touristic activities. Okay, regarding the study programs, for instance, you could be interested in this Master of Science in Viticulture, Enology and Wine Markets, which is a collaboration, a partnership between Bolzano, the University of Verona, Padova, and Udine. So we have master students also from international provinces, so international students. Mountain viticulture and mountain enology. There is a definition of this concept, which is related to the height of the vineyards, so vines growing over 500 meters above the sea level. Slopes, as you can see here, slopes are very steep, higher than 30%, but it doesn't mean that these are only mountain, let's say, Alpine region. It could also be islands, because also we have students coming from Sicily, from the islands, also from Capo Verde this year, because they would like to study how is the management of these steep places. The steep places means that there are some difficulties, terrace systems to overcome these problems, the steepness. We have very small farms, less than 1 hectare, for instance, and with different crops, not only vine and grapes, but also apples, for instance, in the flatland. Most of these farms also have some hospitality. They are bed and breakfast, actually, also to get income from different origins. The wines are niche products, very low produced in very low amounts. And there are some impediments to mechanization. So mechanization is very important because of the orographic conditions that can create all these obstacles. Okay, and also the innovation is very difficult because family-run businesses. So investments, possibility of investments are quite low. So this is the focus of the University of Bolzano, so trying to help the territory, okay, to develop the territory. In this policy of developing the territory, the next step will be the activation of a Bachelor of Science in Mountain Enogastronomy that will start next year, next academic year, in 3 languages: German, Italian, and English. Going to the research, this is our facility. It's called, it's a technology park, also called the Noi Tech Park. Noi in Italian means we, so our park. Noi in German means new, so something new. And it's a partnership between private companies, but also the province, meaning the public institutions. Not only food and wine are research on food and wine is located in, but also automation, green, and alpine technology. We are in the 3rd floor of this building. This building was a former aluminium plant. Okay, what is the focus of our research? We have some high resolution, we call it high resolution analytical techniques. This is for instance, 2D GC, so bidimensional gas chromatography, coupled with mass spectrometry, time of flight mass spectrometry. This is an instrument, not really a routine instrument. We would like to make it a routine instrument, and I will show you how. So the analysis, the fingerprint of wine and other products is put in relationships with the winemaking process. So we are studying the effect of the winemaking process, including fermentation, so of course, but also storage of the raw materials and aging of the finished product, together with the chemical analysis and with the sensory evaluation, the sensory properties of the products. I will start with this paper. This paper has been published last year by our collaborator, a PhD student. We were asked, of course, our research are always very much in contact in relationship with the needs of the industry, of the companies, which is the main topic of the technology park. So a combination between basic research and technology transfer. So a company asked us to, actually, this was a partnership between a distiller of grappa, producer of grappa, and a producer of closure system of corks, and our lab. They wanted to understand if what was the best solution as a closure system for grappa bottles. If the cork bark, okay, is still a good option, or we have to choose something else because the technology, of course, is giving more product and more advanced products. So we studied the evolution of volatile compounds, non-volatile compounds, and other parameters of the cork and of the grappa sealed with different stoppers during several months, up to 24 months. Here you can see the 4 different closure systems that we use. They are called in Italian mushroom corks, stoppers, because they have the shape of a mushroom, also called T-stops, where the main part, which goes in contact with the neck of the spirit drink, can be common granulated cork, synthetic, so they are practically olefinic polymers. Also another competitor of this one, another polyphenic polymer, and let's say the sanitized cork microgranules blended with the polymers without addition of glue. You know that probably the use of glue and other ingredients, components of a polymeric mixture could be released in the grappa or in the wine or other beverages. So the company wanted to check what was the quality of the grappa stored in these different conditions. And so we did HPLC analysis of the non-volatile compounds, then GCMS of the aroma compounds, volatile compounds, and sensory analysis. Also sensory analysis, of course, it's important because at the end, the chemical composition is important for quality control, but also the sensory quality and acceptation by the consumers should be taken in strong account. So cork, natural cork, even if it's microgranules or of cork, is the blue, are the blue bars, and this is the liquid absorption by the stoppers. You can see that the natural material, which is supposed to be best as a commonplace, instead is absorbing a lot of liquid from the distilled beverages. I must say that these grappa bottles were kept horizontally just to increase let's say the rate of all the study. Okay, this is from another point of view the volatile profile. This is a GC. We will go back to GC later. A gas chromatographic profile of volatile compounds, 13 different compounds that are present in the distillate, and how they change during the aging. You can see here in this plot a PCA, so a principal component analysis of the volatile compounds present in the different grappa, okay, the liquids. From time 0 here, time 3 months, time 12 months, time 6 months here, 12 and 24 months. So, and these are the compounds present in the different samples, so the variables to be clearer. You can see that the time has a strong influence on the chemical composition of volatile compounds. And the plot says that the grappa stored for 3 months is completely different than grappa stored for 6 months here or 24 months. So even if there was no fermentation after bottling, because we are talking about a product which has 38% of ethanol, so nothing can happen inside, practically, biologically. But anyway, the evolution of the volatile compounds is clear. Okay, now we wanted to check what is the difference between the different stoppers. And the difference between the different stoppers, the quality of the grappa closed with different stoppers, can be seen here in the trend of non-volatile compounds over 24 months. You see that the blue line, which is the natural cork, granulated natural cork, produces some non-volatile compounds. Some of them, they were not identified, to be honest, but you can see here the retention time in HPLC is higher than the synthetic polymeric stoppers in many cases. Okay. Let's go back to routine analysis and let's say low resolution analysis like refractometry, UV-Vis spectrophotometry, of course, spectrophotometry. You see that after 24 months, the blue, the grappa stored in bottles closed with natural cork, which are these ones, have become brown. These samples are not of natural grappa. These samples were reconcentrated. Is grappa reconcentrated to remove the alcohol and to make the analysis, to perform the analysis of non-volatile compounds. So only by reconcentrating the samples, we could see that the grappa has turned into this brown color. From the sensory point of view, the tasters, when they were tasting the grappa, the natural grappa, could see some color differences, but only by reconcentrating and removing the alcohol, this was very clear. Okay, so at the end, we could need just a very simple UV-Vis spectrum of the grappa at 420 nanometers. You know that 420 nanometers is the absorbance of the brown color in all the food products and beverages. This is a standard wavelength. So the commonplace that the natural material should be better for storing spirit drinks is not true. So synthetic and polymeric closures are much better, for instance. And these are the conclusions of this first paper. Now, I would like to talk a bit more on the high resolution, or let's say very high resolution methods to characterize the quality of our wines. This is Moscato wine and analyzed by our bidimensional gas chromatographer. So bidimensional gas chromatography means that we have not only one coordinate, not only the x-axis, but also the y-axis, which are, this is in seconds, time in seconds, and this is times in minutes. So compared to what I showed you before, in which we have 50 minutes here in the x-axis, and this is the abundance of the peak of the signal. Actually here, the abundance of the signal is given by the color of the spot, because in the y-axis you have another coordinate. Okay, so we have two columns. The big one is this one, and it is the first column. The other is inside this small oven. This is practically an oven. It's a 1 meter, more or less, of a small GC column. Practically, there is let's say, an interface which enables to stop and go the peaks in order to produce this kind of plot. Each, I will not go into details because now I think we don't have time, and neither probably it's interesting. What is interesting is the final goal. The final goal is to have an aroma map in which all the aroma compounds are here, about 79 different aroma compounds. Here is the list of identifications. Identification is done through a software, but unfortunately the human expertise is very important in identifying these peaks. And each peak practically can say something to us related to the origin of the raw material, the winemaking technology, varietal aroma compounds, of flavors, of taints, and I will show you how. For instance, this is practically let's say a more a study which has been done later than this first one study, in which we have analyzed the Pinot Noir, so a red wine produced in Alto Adige. This is identification of the peaks, but maybe it could be very much more sexy if I can associate to each peak a flavor. For instance, 3-methylbutanol is a higher alcohol, and it has the flavor of whiskey. Okay, it's present in whiskey. Here on the top we have ethyl esters, which have a very strong fruity flavor. Here in the middle we have terpenes and benzaldehyde and aldehydes, which give a very interesting flavor of mandels. Furfurale is this pot here, which is typical of a wine which has been stored in oak barrels, toasted oak barrels. Here on the right, we know that phenylethanol is related to the rose odor, as well as phenylethyl acetate, which is the practically the ester coming from phenylethanol, which has a floral flavor of honey. Then we have some dairy flavor, and these components, all these components, build the flavor of the wine. Here we can also follow what happens during the fermentation. This was a Pinot Gris produced by a company. Sorry, this is a mast, the frozen mast at the start of fermentation. During the fermentation, you could see different. This was, for instance, always Pinot Gris on the. This is actually 11th January and 17th of November, and you can see how is changing the formation of aroma compounds from the beginning and going to during the aging. The two different Pinot Gris are A, which is this column here, is where only alcoholic fermentation took place. And here, when alcoholic fermentation plus malolactic fermentation took place. So there are some differences. The malolactic fermentation gives a more complex, let's say, flavor. Which is very typical of the different fermentation. Then I told you about detection of flavors before the off flavor can be recognizable from the sensory point of view. Here you see that our red wine from a region of Italy has a Brett character. Brett is an off flavor of wine, which gives a very bad odor of sweat. It's called horse sweat or well, pharmaceutical. It's something very complex. But here you can recognize the off flavor from a specific molecule, which is 4-ethyl phenol, volatile phenol. So if we get this spot, it means that there is a danger that the wine could be contaminated. So the barrel, practically, the oak barrel is contaminated by this off flavor, which can reduce the quality of the wine and also the commercial quality of the wine. Recently, in a very recent work by a student who graduated in December, we were able not only to analyze with the help of Eduardo, and I think he will talk about this later. We're able not only to identify the usual volatile compounds, but also volatile compounds which are related to the grape variety, pyrazines, thiols. They are present in Sauvignon Blanc in only a few grape varieties, such as Sauvignon Blanc. Together with the sensory analysis that we performed in the lab, we can get a map. In this case, this is a map. Let me check. A map in which all the sensory properties of the wine has been put in relationship with this multiple factor analysis with the molecules, the volatile compounds, and to check what are the molecules producing which sensory property, and if the defects can be associated with some molecules or not. Here you can see that the overall quality is due to sensory property that the tasters identified as passion fruit. And this passion fruit is given by a molecule like beta-damascenone, which is a derivative of carotenoids, which is present in the grapes, by terpenes, and it is in opposite, in negative relationships, in negative correlation with some other components like methoxypyrazine, which give a very herbaceous flavor, and also the woody aspect. When a wine is too woody, Italians do not like it, because here the tasters were all Italians. And you can see here the same graph, the same plot reporting the samples. So practically there were some wines, which are these ones, which are related to, would be present in this quadrant, which were not liked, whereas all these other wines were liked a lot. And the wines which were very appreciated were the ones with a tropical fruit flavor, but not the ones with a high, intense woody flavor, or green pepper flavor, or tomato stem flavor. These are typical Sauvignon Blanc, but Italians do not like them. Okay, so this is the way also to help the companies, because this wine was traded by a company, to help the companies to understand to which countries they should deliver the wines for the purchase. So these wines were not. This is South Africa, okay. This is Argentina, but it was a chance. It was by chance that these two wines were produced in these two countries. So they were not liked by the Italians. Instead, I don't show the data, but we also have this data. Those wines were very liked, very appreciated by German tasters in another study done by another laboratory in Germany with the same wines. So we can say to the company, look, these wines can be sold to German consumers, whereas these other wines from, for instance, New Zealand, Australia, and some of them from Italy, should be sold to Italians. So you should change your marketing strategies. During the pandemic, we had to develop sensory app because we were not able to have tasters in presence. With a sensory app, we're using a smartphone. This is the QR code. We were able to train the tasters and also to make the sensory assessments. I think my time is finished. Sorry for being so late. This is an outskirt of Bolzano with a very nice church of Sancta Magdalena, which gives the name of to our wine, the red wine. So I hope I can see you in Bolzano in presence and not only with this web conference. Thank you very much for your attention.
So, hello, hi, thank you very much for the participation. My presentation will take from where Professor Boselli just finished. Actually, I'm going to cover a small part of the presentation, as I think just 15 minutes are left. So I divided the presentation in 3 parts, in which I went to present 3 research topics we have been covering in our laboratory in the past years. I will cover them really briefly, just to give you a short account of our activities. Please let me know if you have issues in seeing the presentation. So in the first part, I'm going to present you our research on unconventional cyclic condensed tannins, which is a particular phenolic component, phenolic class of molecules in wine and grape and natural products, which we research a lot. Then identification of markers of authenticity. Professor Boselli talked a lot about varietal compounds. Sorry, 1 second, I check my, okay, perfect. Varietal compounds responsible for traits of the wine and so on. We will be dealing more than with polar compounds in solution than with volatile compounds in this case. And then chemosensory fingerprinting of wine, as Professor Boselli correctly just introduced. This is a big part of our research. So the first chapter dealing with unconventional cyclic condensed tannins. Condensed tannins, just to give you a brief overview, it's a very important chemical class in wine and grape, making up a big portion of the phenolic compound in wines. These compounds are characterized by a staggering structural variability, so they can be present in many different forms, molecular weights, and so on. Our interest in this is due to the fact that this variability is strongly related to viticultural and enological factors. So studying this chemical variability can give you a lot of information on viticultural variables like grape variety, geographical origin, for example, and so on. And on the other side, the enological, so the winemaking operations can also impart variability to the composition of these phenols in wine. The key point is that these compounds bear a wealth of information in terms of dependence of viticultural and enological factors, but on the other side, this complexity and also their tendency of evolving over time in wine renders this compound very difficult to be studied. So in this aspect, there is a subclass of these compounds called cyclic proanthocyanidins, which our group have also helped in exploring and also finding for the first time. This particular subclass of chemical compounds have shown improved stabilities over time, which is a good thing because it allows us to study them and to use them as chemical markers for in more reliable ways. Also, it has shown different chemical properties than the other condensed tannins, which makes them quite interesting for several reasons in terms of quality of wine. So these pose some presented some opportunities in terms of potential application of these compounds, not only as analytical chemical markers, but also as potential for potential application in enology. And so our goal was to define these compounds are brandly new studied, so there are actually even no chemical standards available. So the reason for our necessity of isolating them was due to the use of them as chemical markers, need of chemical standards, and also the possibility of applying them for enological applications. So what we needed was a protocol for their extraction, which in perspective could be also scalable, food grade, giving with no use of solvents, for example, using very cheap conditions, for example, room temperature, using water as extraction, but we didn't know which were the main factors influencing the extraction, which luckily, actually, we got a lot of information from vinification, because vinification in the first part is nothing else than an extraction taking place during an evolution in which ethanol is produced. So you start from 0% of ethanol and you end up to a high percentage of ethanol, high up to 15%, for example. So we had already some information from which we started. In order to study so many possible factors influencing the extraction, we used an experimental plan, an experimental design, a Plackett-Berman design, which is meant to study many factors with a small amount of repetitions in order to identify which factor could have been the most significant. I'm not going into much detail. I want just to show you our aim was to find as a first response to find actually two possible conditions. Sorry, the first one, the condition that were improving the extraction of these cyclic compounds as much as possible, and in the second case to find the condition that could improve the extraction of them with respect to the non-cyclic, so the conventional ones. This has several reasons for the application we had in mind. And so we use these two goals. With these two goals in mind, we set up a series of analyses applying that experimental design I mentioned, and the analysis were done by LCMS. And here you can see the chromatogram and the positions in the chromatogram of these compounds assigned several positions, and you see that already with a single sample of wine the complexity is quite important. This allowed us anyway to set the response, response parameter for this experimental design in terms of the area of the peaks and the percentage of the area of the specific peak for the cyclic compounds over the total proanthocyanidins profile. At the end, what is important is that we found two conditions that were very interesting for us. The first condition gave us the possibility of a shorter extraction in terms of time, but actually required us to use 10% of isopropanol as the organic modifier. On the other side, and this one actually was kind of improved the ability to extract a higher proportion of the cyclic compounds with respect to the non-cyclic ones. Instead, another condition actually allowed us to not to use any organic modifier at all, working at room temperature for slightly longer times. But you see how, so this we are just used water for this extraction, and you see how actually very cheap and scalable this type of extraction is. You don't need any solvent, you don't need any heating. So, I mean, it's kind of interesting. And this actually improved and optimized the extraction of as much as possible of the absolute quantity of these compounds. So we had these two competing possible protocols. For continuing the study, and the next part is about the purifications of the extracts. We decided to use the second one because, of course, we extracted more material, and in the purification we aimed also at removing the interference, so then let's say the non-cyclic compounds. We studied, I'm not going into detail here because we did many tests, we reviewed a lot the literature, and in the end we end up with 5 competing protocols that we tested, and as you see, the protocols are quite complex because unfortunately these interferences in the end were not really completely removable, because the first part, if you remember a few slides ago, I said The first part of the protocol was to produce the extract with the enriched cyclic components. A second part of the study was aimed at isolating specific compounds, which unfortunately was not possible, not even after 4 different separation steps, because these, unfortunately, some of these interference are really coeluting in any condition. So it was very, very difficult, and we are still working on this. So as a conclusion and future work, the mass suitable extraction condition involved a really cheap and scalable condition, obtaining completely food grade extracts. Also, I forgot to mention the raw material we started with for the extraction. It's grape pomace, and this grape pomace we use come from a grape variety that is used for making sparkling wine. And actually, this means that this grape pomace is completely not is unfermented, so doesn't contain already ethanol, and also has not been already extracted during the fermentation. So it's a material that is available on certain quantity, so it's applicable also for a scaling to industrial levels, but also allow you to not to have ethanol inside, which is an advantage, as you see in this case. Then the purification strategies we attempted did not allow us to actually purify to the single pure compound these cyclic compounds, although we obtain enriched extracts, and our future work will involve, of course, new attempts at both pre-processing the raw extracts to remove the interference. For example, I mentioned the enhanced stability of these compounds. So, for example, maybe applying harsher pHs may destroy part of this interference and retain these compounds. So these strategies are common in order to remove what you don't want and keep just what you want. Also modify the extraction by adding salts, because we know the extraction for winemaking, so the fermentative maceration, is in presence of high amount of salt. So maybe we could try to reproduce a situation that we have during fermentation to take kind of inspiration from what is done for winemaking for improving our protocol. Then using some oxidative conditions, still, or present on metal catalyst, in order to get rid of what we actually this interference, and then modify the purification, either by improving the semi-preparative HPLC method, using tailored modification to the gel filtration or size exclusion chromatography, or even attempting different type of chromatographies like countercurrent chromatography. And then further improving the extraction method, also using dedicated experimental design, which are aimed at specific parameters, because this is explorative experimental design told us which are the significant factors, but of course did not allow us to very deeply optimize them. So this is a thing that should also be done. In the second chapter, I will skip very briefly. The main aim was to, as Professor Boselli told you before, to apply these chemical markers for study of authenticity for grape variety. In particular, in this case, we have been doing this part of the research is doing in 3 different steps, let's say. The first part involves studying chemical markers for grape variety, so which are consistent across a population of different samples for the grape variety, studying this along a vinification. So all these vinification steps can modify the chemical profile, and our goal was to find a part of the chemical profile that actually can be seen as consistent, so stable over winemaking. So you see here images of what it's doing. We went, harvest the grapes, brought them to the laboratory, performed the vinification in strictly controlled conditions, and then store them. All this was monitored analytically, doing bidimensional gas chromatography that Professor Boselli just presented to you, liquid chromatography coupled to mass spectrometry, so to check for these phenolic compounds, for example, and other basic enological tests, in order to monitor the fermentation, monitor the storaging, everything under strict control, so that we could apply a experimental design, which is in this case is a full factorial design, meant for example, studying 3 factors. In this particular case, we studied 3 specific factors, like the effect of grape freezing before the fermentation, fermentative maceration, and malolactic fermentations, all repeated in replicates and monitored over time. So on one side, as I said, we want to look for chemical parameters which are stable under all these conditions. And on the other side, we want to study instead how the chemical parameters or the chemical profile, the general chemical profile, evolve under these conditions, and also compare the different conditions. We were in particular interested in interactions, because the interaction between these factors can be really telling about specific effects or specific phenomena taking place during the fermentation, which will improve our knowledge about these systems. So the expected outcomes here is finding chemical compounds unaffected by the vinification, studying the evolution of the chemical profiles over time, and understanding the relation between the chemical profiles and the final wine quality. Next step, the second part of this chapter 2, is doing the same but for geographical origin. And we have been studying already Chardonnay and Sauvignon Blanc, obtained from 4 different continents, in order to find common chemical profile and across all these geographical origins, and also integrating not only the chemical but also the sensory data in order to get a fingerprint for this wine. That could be the part of this fingerprint that is actually independent from geographical origin. In the third part of this study, we are going to monitor the effect of aging. Aging, it's as Professor Boselli told you before, it's a strong effector of how the chemical profile evolves, and so finding stable markers, for example, for variety, also across aging, will be a huge help for authenticity studies, because of course for authenticity studies, for something that is actually evolving over time, it's important having something that is more or less stable over time. Like for example the CPAC compound we mentioned before, there are hints that they could be stable over aging condition in wine. So we will apply, of course, harsher condition that will mimic the condition that wine experience over time in bottle and or in barrels, and we will try to model these changes and find features that are consistent over time. Finally, in the last chapter, this same approach, of course, which entails a lot of statistical analysis, will be applied also as a predictive tool in order to integrate the activity of the enologists in the wineries for helping in decision making, as Professor Boselli also mentioned. So in this case, the main approach is to start from the chemical profile before winemaking, so grape and must, and then go to the chemical profile of wine, also intertwined with the factors that were selected for winemaking, so the different operations, what has been done, and so on, plus the quality of the grape. All this, of course, contributes a lot for the final wine sensory profile, that in the end is what it's interesting for the market, because the market doesn't know anything about chemicals, doesn't know anything about tannins. In the end, what is important is the effect of these things on the sensory profile. So this scheme here, in the end, what is important for the market is this. But what to make this, what is very important is this. And in order to get this, so the wine chemical profile, in order to allow this to be reliably defined, we can rely only on the grape quality and the decision that the enologist, so the winemaking of operation that the enologist makes. Our idea is, of course, since nowadays the enologist decide everything, of course, he has the responsibility for these decisions, and most of it is based on his experience, is to intervene with a support system that actually takes into these analytical tools into consideration. Using this analytical tool, we can use study vintages, for example, of vinifications and the resulting wine, and knowing all this whole system for specific factors, of course, we could our aim is now to create multivariate regression models, so taking into consideration multivariate statistics in order to create predictive model that can help the winemaker in decision making. This is a general scheme taking into account, you start from vitinological factors producing wine, and of course this combines the analytical methods with sensory methods in this workflow, and then the statistic, as Professor Boselli already have shown you, the multiple factor analysis. This could be a possible explorative step, followed by some more quantitative step like multivariate regression, using data fusion techniques also, for example, in order to get a wine fingerprint that is, of course, bound to the initial vitinological factors. Overall, this could give a lot of information and allow us to also help the enologist in making decisions during winemaking. So, as expected outcomes is exploitation of multivariate models to explain the sensory profile in terms of the chemical composition, but at the same time also combining the two. And this could be very helpful in the winemaking, in helping the winemaking decisions. On the other side, integrating chemical and sensory profile could be very, very useful because, of course, this is very explorative in terms of understanding what are the chemical components that actually produce a certain marker. As Professor Boselli correctly told you, this is very important. The chemical that you have in the wine, the compounds, are the things that actually are creating the sensory profile, the aroma that you perceive in wine. Therefore, understanding this relation between the chemical profile and the sensory profile, it's fundamental. And then transfer of this acquired knowledge to producer in order to help them in decision making. Thank you very much.
Guys, thank you very much for this presentation. It's pretty interesting because we have a couple of projects ourselves. We're trying to start to look into in-depth chemical analysis of spirit and what we call wine that we're making from maple syrup. So guys, if we have any question in the audience, I will let people ask them. But of course, I had the opportunity to visit their lab in Bolzano, and it's quite incredible. So it's quite different from the usual lab because people are there and they're smelling and they're tasting wine. So it's pretty cool and quite different from what you see in the usual lab. But I think there's a lot of room and opportunity for collaboration. And I think we have question in the group. So Thierry, please ask your question.
Yeah, thank you guys for this presentation. It was very interesting and very impressive. I have two questions. The first one is, how accurate can you correlate the sensory analysis to the GC TOF analysis? Right now, are you able, for example, to say that, okay, I see that I have apple taste in the GCMS and people are actually tasting the apple?
If you want, can I reply to the question?
Yes, sure.
Okay. So I will briefly go and find the paper. Sorry. Actually, we are the accuracy, of course, in these matters depends a lot on the set of samples that you define as reference samples, because it's fundamental to understand that for this type of study you must have reference samples that you can use, so for which you know very well the chemical profile, for example, and then you go and use a panel that has been very well trained. When you have these two things, then the application of, I will show you briefly, sorry if I need to share my screen again. For example, the use of multivariate regression approaches can give you a, let's say, a more complicated but more precise and accurate correlation between the chemical profile and the sensory profile, in terms that you're not considering chemical compounds by chemical compound or sensory descriptor by sensory descriptor, but you are considering linear combination of them. So there are a lot of statistics involved, and also there are methods for validating these models. The problem is to define the range and the extent to which your model can be applied. So you must be very, this entails a lot of analysis, by the way, but in the end, if you're able to define the limits, the range, the frame in which you can apply your model, then you can say that in that frame, your model is accurate. There's no model that could be really universal. What could be universal is the measurement of the concentration of a chemical in solution, but for specific cases, if you must be very good at defining a certain reference in which, so I'm working on this sector, okay, and then those references, of course, are explained in terms of statistical correlation between the chemical and the sensory data you have.
Okay, thank you. And the second is more related to the instruments. In the first cases, it was a GC TOF, and the second one it was a triple quadruple. So, how is the accuracy of the attribution? For example, the GC TOF, how high is the percentage of accuracy or matching? And exactly the same with mass spec, because triple quadruple won't give you a lot of number after the digits. So do you have a lot of options, or because of the separation, for example, you just have a few options in terms of chemical formulas?
Okay, if I can answer to the question on GC, we have different channels of informations like mass spec, retention times, and the comparison of this data with the literature. All the information should match. If all this information will match, also with the third information is the injection of pure compounds. If the three information will match, then we can say, okay, this is beta damascenon, this is beta phenylethyl alcohol. So this is not just the response of the software of the GC. We are always re-elaborating with our expertise the identification of the peaks of the molecules.
Then there is maybe a little bit of misunderstanding. The triple quadruple analysis I showed you was for the liquid chromatography.
Yeah, no.
Not
you have an attribution of the mass with the quadruple. So it would always bring the question that did you have just one molecular mass, or do you have several, and then you decided because of your knowledge?
No, of course, the point is a high resolution mass spectrometry is something that it's really helpful because it allows you to do many things. Besides the accurateness of the and the precision of the attribution of the mass, and also elemental composition. At low resolution, you still can do some work because there are certain things that you can do. I didn't show you because we didn't have some. I should have spent 2 hours of presentation, but the first thing we did on the study on the cyclic proantocyanidins was specific studies done with high resolution mass spectrometry, by the way, so we could do the same thing on both the analyzers. That entailed some isotopic exchange on the compounds in order precisely to attribute the structure. So we did a lot of testing, and also for those chemical compounds, there are also the backup from nuclear magnetic resonance results. So we don't start from zero. Besides, there are several things that we can do that we found about these compounds, for example, but also for other things that could enable us to have more information. Of course, the only way to ascertain the actual nature of one compound you see in a chromatogram is injecting the standard. But as I said, for these compounds, there are no standards. So we had to find different ways.
Thank you. And maybe a final one, is the mountain wine better?
Well, what is for sure, well, let's say, due to the heroic conditions, so due to the pressure of the climate, the grapes produce secondary metabolites like aroma compounds, which are different than other geographical proveniences. So I can say we are talking about typicality here, identity or typicality. So the mountain wines have a typicality features which are different from wines produced in the flatland or wines produced in other parts of in other climate conditions. I don't want to say they are better because it would be, I mean, super narcissistic. I say they are different. So, for instance, there is a very nice example, Gewürztraminer. Do you know Gewürztraminer? Okay, it's a wine that can be produced in Italy, so in South Tyrol, in our region, but also in France and in Germany. So the point is that it's the same grape variety, but it can, I mean, the sensory properties are different if they are produced in Germany or Alto Adige, our region. So it means that our producers can only sell Gewürztraminer in Italy. If they go to Germany and try to sell Gewürztraminer to Germany, nobody would drink it. Nobody would purchase it because it's too tropical. It's true. The flavor is completely different than what they expect to have.
Thank you.
Yes, if I may add also, Professor Boselli presented before something like this. In the study about Sauvignon Blanc, we had a comparison with similar study done in Germany on the same wines. And the results actually were amazing. The one Sauvignon Blanc wine that was found the best by sensory panel in Germany resulted the worst here. And the reason was pointed out by the student that understood that actually in Germany reduced wines could be accepted and also sometimes are looked for. Instead, here in Italy, the reduction is considered only of flavor, so it's something that is very bad, and therefore these discrepancies. This is the reason I said you need to define very well your frame of reference in which you're working. And you must understand very well in which situation you are and what you are doing, because as I say, especially for sensory analysis, it's difficult to define a concept of universal quality. And in that same study I showed you before, we try to go in that direction, and the correlation between sensory and chemical analysis could really help in this.
Okay, thank you. And thank you again for the presentation.
We should mention what is a reduced wine, because it's something which is probably clear to us, but reduced wines or reductive wines are the wines in which thiolic components are very high. So the thiolic components are at a reductive level of oxidation. This is and they have a specific flavor, which is not always accepted.
Okay, thank you.
Okay, so we have another question from the audience. It's from Andre. So Andre, please ask away.
Thank you guys for the great presentation. I was super excited here watching you. Actually, I have two questions. The first question is about the sensory panel. I want to understand more about the dynamics of the sensory panel that you keep in your lab. Do you keep a trained panel, or do you need to train for each project that you have?
Unfortunately, we have to train persons for each project because of two reasons. The first reason is that we love to teach the students how the sensory tasting is done, but then after 3 years they go. Okay, and most of them are coming from different parts of Italy, not only from Bolzano. So in most of the cases, we have to retrain the panel. Okay. We don't have some technicians or some people who are working in Neutech in our facility come to participate to sensory projects, but many of them are not consistent. Many of them come for a couple of sessions and then they go. So it's difficult. The most difficult part is to train the sensory panel for us.
Yeah, and we should also say that before our laboratory was installed here at Neutech Park, there was no sensory analysis done in the university. So there was no structure behind. and therefore the organization had to be started by us, and this of course, and relying on the students, of course. So.
Okay, the other questions about it's super nice what you've done with the 2-dimensional chromatography and the results with malolactic fermentation. As I saw in your presentation, you were making the wine each step for this project, and I'm curious about this malolactic fermentation. Did you inoculate a malolactic bacteria? It was a co-inoculation. It was
a co-inoculation. A co-inoculation with yeasts and malolactic bacteria together.
Okay, how long it took? Do you remember?
The fermentation?
Yeah, the malolactic fermentation.
So it's since it's co-inoculation, a couple of weeks. Kept at I don't know, probably 20 degrees C, 22 degrees C. In a couple of weeks, everything is over because it's a co-inoculation. So
okay,
very fast, quite fast.
Yeah. Thanks a lot. It was it. Thanks again. It was great.
Okay.
Thank you.
Do we have any other question from the audience? Mohammed, go ahead.
Hello, Professor.
Yes.
And thank you for the great presentation. So my question is that some of your analysis, you have to wait like 1 year, something like the evolution of the phenolic after the bottling. So my question is that, is there any kind of shortcut? I mean, for example, in some of industries like power plant, oil and gas industry, when they are doing the condition monitoring on turbine oil, compressor oil, which can start its degradation after like 4 or 5 years, instead of waiting for 4 or 5 years, they will do like a standard test to simulate those 5 years activity. They create a very severe and harsh condition to create a harsh environment which simulate those 5 years activity. So is it possible to do the same for your project?
Very, very difficult. They are the so-called shelf life studies, so accelerated aging. But if you increase the temperature, because we are talking about this, if you increase the temperature, the results are completely different than if you just keep the wine at room temperature for several months. So the results are not comparable because these are food products. So it's different. This is another point, critical point. So, yeah.
If I may add, there was if you remember, Emanuele, that study about some Solera, which was a study under some accelerated aging condition because they wanted to reproduce the aging of this product. But in the end, for wine especially, also regulation is very strict. So even if they existed, this method wouldn't be allowed probably. So actually you have to, and also you want to know what is that is getting to the consumers, and this is actually the natural evolution of the product in bottle, for example. I've seen studies reporting the evolution in bottle of the yeast in sparkling wines after 10 years. So some guy did the study for 10 years of the same bottles of sparkling wine, studying the dead yeast, how it evolved, how it precipitated, and so on. So there's people doing also this.
Thank you very much.
Okay, is there any other question from the audience? If not, I would like to thank our guests once again. Thank you for this very interesting presentation, and I'm pretty sure there's a lot of room and opportunity for collaboration. So we have a lot of tools here, and eventually we don't have your expertise in terms of spirit and wine, but we have a lot of analytical tools, and I think we could probably gain from sharing information one with the other. So eventually, if the restriction ease up with the COVID, it would be nice to have people around from your guys coming here and our guys going there. Okay?
We are also very interested and we're looking forward. Thank you very much for the invitation.
Thank you very much.
Thank you again, and see you soon, hopefully.
See you.
Goodbye.
Have a nice afternoon and evening. Okay.
You too, guys. Enjoy. Enjoy.
Okay. Thank you. Bye bye, Jean-Michel.
Bye.
Bye bye, Andre.